Now this is like there is another approach to solve this question using equation of pair of tangents. So let me first of all explain you equation of pair of tangents drawn to a circle from an external point. Suppose we have this point as h comma k, and from this point tangents are drawn to the circle, and we can draw two tangents from an external point. Now combine equation of these two tangent lines, we say equation of pair of lines. Equation of pair of lines is the one where we multiply two lines. For example, a1x plus b1y plus c1 is equation of a line. If I multiply this with another equation of a line, then it becomes equation of pair of lines. And you can see equation of pair of lines is a degree 2 equation where we have x square term, y square term, x term, y term, or in general it will take this form. So degree 2 equation, pair of lines is a degree 2 equation, so it will take this form. So the pair of these two lines, equation of pair of these two lines, or we can say pair of tangents, is ss1 t equal to t square. This is how we remember this. And in this ss1 equals to t square, s is equation of circle, or it can be any conic. In general form of equation of circle, replace x by h, because you want to draw tangents from h, so replace x by h and y by k. In general form of equation of circle, or in general conic, we replace x by h and y by k. And this t is equation of tangent. We have to replace here equation of tangent drawn at h comma k, drawn to circle or any conic at h comma k. Now there's no relationship with tangent here. Just to remember the results, just to easily learn the result, we are just making an analogy where this part will come from the tangent result, but no tangent is involved here. So if you write this, it is equation of circle x square plus y square minus a square into equation of circle where we replace x by h, so it is h square plus k square minus a square equals to t square. Equation of tangent drawn at x1 y1 to a circle whose center is at origin is this square of this. So this is equation of pair of lines. Right, so in this case we could write this, we can say this is equation of pair of tangents p and pb. This is degree 2 equation. Now we know we have a result, angle between pair of lines. Angle between pair of lines is 2 root of h square minus ab over a plus b. It's a formula. Angle between pair of lines is this. If alpha is angle between pair of lines, then tan alpha equals to this. Now we know alpha is pi minus theta, so we replace pi minus theta, and on this side, this we compare this equation with ax square plus by square plus 2hxy, and then we have 2gx plus 2fy plus c equal to 0. If we compare this general degree 2 equation with this equation of pair of tangents, we can find coefficient of x square, that is a, we have to replace here coefficient of x square. So we have to simplify this first and identify the coefficient of x square and replace here. Don't get confused, this a is a radius here, and this a and a are not same. This is the radius here, so for timing you can change it to arts, and this is coefficient of x square. So we see coefficient of x square from this side, replace here coefficient of y square, that is b. So we find coefficient of y square, replace in place of b, and h is coefficient of xy divided by 2. So we see coefficient of xy here and we divide by 2 and replace here. So if we do that, we'll get equation of pair of tangents.